So before we start today's lesson, we need to do a quick little review. Each one of these sections of an XY coordinate plane actually has a name, an identifier. They're called quadrants. And we start over here by calling this quadrant 1, and we go counterclockwise. So this is quadrant 1. This is identified as quadrant 2. This is identified as quadrant 3. And this is identified as quadrant 4. Today we're going to be identifying which quadrants our graphs for our hyperbolas are going to be in. So our hyperbola equation is going up a little more complex from our standard form. So we now have an h and a k involved. Remember, the number up here for a implied some kind of vertical either stretch or shrink. If the a was bigger than 1, he was vertically stretching. If it was smaller than 1, he was vertically shrinking. So now we need to look at what the h and the k mean. So the first thing we're going to talk about is this h right here. I colored in h green so we could help identify it when we were actually working with it today. So anytime I'll use green, it'll be a reference to h. And h is like, do you remember back in chapter 1 and 2 when we were trying to translate graphs left and right? It was an inside move with the x. So here is our inside move with our x. If you had an inside move with the x, it told you that we were either moving to the left or to the right. And if you remember, if this was a minus h, the inside, a subtraction, always told us that we were then moving to the right. And if our inside move had an add, we knew we were moving to the left. So whatever this inside h with the x is, it tells us to move to the left and the right. The next part is the k. And if you remember from back in chapter 1 and 2, when we had an outside add or minus move, we knew that told us to either go up or down. So if you recall, if it was an outside add problem, we were actually translating our graph up. If it was an outside subtraction problem, we were translating our graph down. So we're going to be using what we remember of chapters 1 and 2 to translate our hyperbolas left and right, up and down. Now there's something new that we need to remember with these h and k's. If you are translating and moving to either the left or the right, that means that our left and right x equals asymptote is changing. So h gives us a new asymptote, and it's always an x equals something asymptote. And our k is moving up and down, which means we have a new y equals asymptote. So you need to watch out for your h and k's because they're going to be moving our things to the left and to the right. So this is going to be our first problem, and we need to identify what the -4, the +2, and the -1 do for us. So reviewing our h's and our k's, my h is the thing on the inside done to x. So I have this added 2. So the added 2 on the inside, here's my added 2 on the inside. It told me to go left 2. And if I was moving left 2, that means my entire asymptote also goes to the left 2. So this is all because of this highlighted green 2. And if I'm going to the left 2, that means I'm going over this direction 2 spots. So 1, 2. That means my new asymptote is right here. So my new do not cross line is right here. So new asymptote. And it cut the x-axis, so it is an x equals line, and that's at -2 right there. So my new asymptote is at x equals -2. The k is this -1, and this -1 was an outside move. So if I saw a -1 on the outside, according to my little key, a subtracted 1 on the outside told me to go down, and so I'm supposed to go down 1. And that's all because of this -1 right here. If I'm going down 1, that means I have a new asymptote, and I had to go down 1. So I had to go down 1 spot, and my new asymptote is right here because it cuts the y-axis. That means it's a y equals asymptote. So my new asymptote is at y equals -1 because that's right there at -1. The next last bit is this -4 right up here, and this is what we did yesterday. So the -4 tells us that we are reflecting across the x-axis. And real fast, we need to review what that meant. When we had our original hyperbola had the graphs in quadrant 1 and in quadrant 3, because that's quadrant 1 and quadrant 3. That's where they used to be. If I'm reflecting across the x-axis, they're trading spots. So this is your x-axis, which means he comes down here now, and this one goes back up there. So now our graph, you're supposed to have one down here now, and that is now quadrant 4. And this guy is supposed to now move up here, and he is no longer in quadrant 3, he is now in quadrant 2. So that's what the negative means. The 4 is telling us, because it's bigger than 1, that we have a vertical stretch, and it's by a factor of 4. And what that meant is that you are just going to stretch away. So when we graph it, we're going to be stretching away. So that's what this -4 tells us based off this guy right here. So all of this is going to help us graph it. So here is our graph paper. Consider this almost your new origin. So we need to stretch away from this new origin by a factor of 4, and we're just going to guesstimate it for right now. And remember, it's supposed to be reflected. So we're supposed to be down here in quadrants 2 and 4 now and stretch away. So here is me exaggerating my stretch away by 4, and here's me exaggerating my stretch away by 4. The last bit that we need to do is that we need to identify clearly what are our asymptotes, what is our domain, and what is our range. Our asymptotes, we have the green and the orange asymptotes. So this orange asymptote is where y equals -1. That's the do not cross line. And this green asymptote is the x equals -2, which we identified over here. They're the same asymptotes. Domain asks about all the x values. We used every single x value to the right and every single x value to the left. There's one x value we were never allowed to touch and use. It was -2. So domain is all of the x values, all real numbers, except for x could never have been -2 because he's the do not cross line. Same with the range. The range is all of our y's. We're going all the way down and we're going all the way up. So we were allowed to use all of the y's, but that one asymptote tells us you couldn't touch this one y right here. So we were never allowed to use it when y was -1. And then we actually need to identify what quadrants are being used. Our graph has one down here in quadrant 4. And I have one right up here at quadrant 2. So we are using quadrants 4 and quadrants 2 for our graph. Our next practice problem is right here. We're used to looking for an h and then a k. If I look at this right here, I actually don't have an inside move at all with my h, so I don't have to move to the left or to the right. So we're going to write that we have no h, and what this is going to mean is that we have no left or right move. And if that's the case, that means your asymptote stayed the same, which means my asymptote is still where x equals 0. And now we got to look at the k. The k is the outside move. So right here on the outside, I see that I have a -2. So if I had a -2 on the outside add and subtract moves told us that we were going either up or down. Since it was a minus, we're actually going down. So this is going to be a down 2 move, which means we now have a new asymptote. And that moved our y's. We went down, so it went where y is now -2. So because I have moved down 2, my y asymptote is down here at -2. So I need to draw my new asymptote at -2. So I went down 1, 2. So here is my new asymptote at -2. We tried looking for a left-right move. There was no left-right move, so that meant my asymptote stayed at 0. So here is me keeping my asymptote right at 0. So I kind of have a new baby origin right here. So the last thing that we need to look at is the a. The a is just a 3, so I know that my a is just a 3, which means that since it's bigger than 1, I am going to have a vertical stretch by 3. And what that means, it's a stretch, you're just going to stretch away. Stretches stretch away from the axis of symmetry, or sorry, they stretch away from the origin, and we're pretending our new little origin is right here. We have no reflection. So we're going to stay up here in quadrant 1 and quadrant 3 like we are used to, and we need to stretch away. So here's me saying my stretch away at 3, and my stretch away at 3. Notice we're using this little origin right here from our asymptotes. We're not using this origin right here. So we're kind of comparing to this guy right here. So we stretched away at 3. So we now just need to find our new asymptotes, label them. We need to find our domain. We need to find our range. And I need you to tell me what quadrants we used. So we already found our asymptotes. The green line stayed where x was 0. And my orange line ended up moving down to where y was -2. If these are our asymptotes, these help us find our domain and ranges. Because I know our domain says that we use every single x value to the right and to the left. But because we can't have an x at 0, we can't have it. And the range says everything down and everything up. So I'm using all my y values, but I could never use where y was -2 because he was your asymptote. So y is never allowed to be -2. It had no reflection. So we're still up here in quadrant 1 and we're still down here in quadrant 3. So we used quadrant 1 and we ended up using quadrant 3. So our very last problem today is this problem right here. I see that I do have a left-right move, but I do not see a up-down move. So let's talk about our H, our left-right move first. So I see that I have a +4 on the inside. So if I had a +4 on the inside, that meant that I ended up moving to the left 4. So this is all because of this inside left move. I need to move to the left 4. So 1, 2, 3, 4. There is my left 4. And so here is my new asymptote. So I'm going to write this gave me a new asymptote. It gave me a new asymptote at x equals -4. I have no up-down move. And if I have no up-down move, that meant my asymptote stayed the same at y equals 0. So I'm going to go ahead and color this so you know why that was there, because it refers to these guys right here. And that meant my axis of my asymptote stayed right there. So we're going to treat this new intersection right here as our origin. Now I see that I have a -1 up here, and this is exactly what we did yesterday. So we have right here a vertical stretch or shrink, and then we have whether or not it is a reflection or not. The negative tells us that we are actually reflecting. So what did it used to look like? So here's a giant was. Hyperbolas used to always look like this. They would always be in quadrants 1 and quadrants 3. But if you have to reflect across the x-axis, that means he goes to the other side of the x-axis, which is now down here. And he goes to the other side of the x-axis, which is now up here. So we know when we graph up here, we need to be using quadrants 4 and 2 now. And this is not a number bigger or smaller than 1, which means he is not stretching, he's not shrinking. He's going to be the normal parent function going down in quadrants 2 and 4. So here's me graphing close to this new origin based on our asymptotes. And here is my new one based on that asymptote. So we're close to our new kind of origin. They're normally close. And this is because of that -1 like we were doing in yesterday's video. So now we just need to find out what are our asymptotes, what is our domain, what is our range, and what quadrants did we end up using. So the asymptote, we said that we had an asymptote at x equals -4, and that this asymptote didn't move at all, so it's at y equals 0. Domain is all the x's, so we have all real numbers, but we could not have used the x at -4. Our range is all the y values, and we did use all the y values, but you couldn't use it when y was 0. And because of this reflection, our quadrants moved. So we're now in this one, which is quadrant 4, and we're now here, which is in quadrant 2. So we used quadrant 2 and quadrant 4.